Let's talk about systems of inequalities today. As a warm-up to our systems of inequalities lesson, let's take a look at inequalities where you have just one linear inequality at a time. So the warm-up is which side should be shaded. All right, so on our first inequality on the left-hand side, we have our inequality is in slope-intercept form. We can see it as a y-intercept of -5 and a slope of 2 over 1. We also can see we have a dashed or dotted line because the inequality does not contain the equal to part. So the values or the ordered pairs immediately on that line are not parts of the solution. So one side is a solution, or one half plane is a solution. The other contains all of the ordered pairs that are not solutions. So in this case, we look at our inequality symbol to determine that if it's greater than, we want to shade above the line. And the upper side of the line in this case is, it kind of looks like it's to the left, but it's really on that side, because from any point on my line, if I go straight up, that's going to cover that left-hand side of the boundary line that I shaded. Now, in our other inequality, we have standard form. And when we have an inequality in standard form, we can't just look at the inequality symbol and say, oh, it's a less than symbol shaded below, because it doesn't always work like that when it's in standard form. Instead, we choose a test point that's not on the boundary line. So I've got my boundary line here, I can see is in blue, and I can tell that 0, 0, or the origin is not on the boundary line. So let's test that point and see if it's a solution. And as we saw in our last unit, or our last video, plugging in a 0 for x and a 0 for y makes this actually a very easy calculation. 2 times 0 plus 3 times 0, that's just 0. So it's really asking us, is 0 less than or equal to -12? Again, to kind of help give you that visual, think about your y-axis and where those numbers are. 0 is right at the origin, -12 would be way down here. Is 0 less than or equal to -12? No, of course not. 0 is bigger than -12. So that tells us that the origin is not a solution because this was a false statement here. So that means that all of my solutions are going to be on the opposite side of the boundary line of the origin. So I want to shade the lower side this time. And that's because my test point, 0, 0, was not a solution. So let's see how that applies with systems of inequalities. So first of all, what is a system of inequalities? It's when you take two or more of those linear inequalities and put them together in the same system. Just like we studied systems of equations in Unit 3, we're looking at putting two or more inequalities together to make a system of inequalities. Now, a solution to a system of inequalities is any ordered pair, so any point on the graph, x comma y, that satisfies every linear inequality in the system. Okay, so when I say satisfies, I mean it makes it true when we plug the numbers in. And it has to work or be true for every single one of the linear inequalities in that system, not just one of them or two of them, but all of them, depending on how many there are. So let's check to see what this looks like. Here we have a linear system of inequalities with two inequalities. And we're going to test each point and see if it's a solution to the entire system. So we have to check, is 3 comma 6 a solution to both of those inequalities? So let's test one at a time. 2x plus y is greater than 8. Okay, so we're going to substitute in for our variables our numbers. Let's see, it says the x coordinate is 3, the y coordinate is 6. All right, got to do a little math here. 2 times 3 is 6, and 6 plus 6 is 12. Is 12 greater than 8? Yes, it is. All right, so that doesn't mean it's a solution to the system yet. It just means it's a solution to the first inequality in my system. Let's check our second inequality. Okay, substitute in our x and our y. And we'll check here and see if that is a true statement or not. So x was 3, y was 6. That gives us -3 plus 6 is less than or equal to -4. Well, -3 plus 6 is 3. And is 3 less than or equal to -4? No, it's not. -4 is smaller because it's a negative number. So this one is a false statement, so that one does not work. So actually, 3 comma 6 is not a solution to this system. Because it did not work for each inequality in that system. Let's check the second example. We had 5 comma -1. So let's start with our first inequality. 2x plus y is greater than 8. And when we substitute in our values for x and y, let's see, x is 5 this time, y is -1. We get 2 times 5 is 10, 10 plus -1 is 9, and 9 is greater than 8. That's true. Okay, so we're good there. Our second inequality was -x plus y is less than or equal to -4. All right, that's from up above. And I plug in my numbers. Okay, so negative and then the x value plus the y value is less than or equal to -4. Now, when I add these two together, I get -6. And is -6 less than or equal to -4? Yes, it is. -6 is actually less than -4. So that one works as well. So this ordered pair, 5 comma -1, is a solution to each inequality in the system. So it's a solution to the entire system. All right. The hardest part, I think, of finding your solutions to a system of inequalities is not the boundary lines, but determining where on the graph, what region contains the solutions. So here we already have the lines graphed in place. And what we're going to do is try to determine which region contains all of the solutions. So if we look at this first inequality, y is greater than 4x minus 3. That's going to be the dashed line because it's a strict inequality of just greater than but not equal to. So that's going to be this one here. Y is greater than 4x minus 3, which means this one down here is y is greater than or equal to -2x plus 3. That's my solid line. And anytime that we are shading for the solutions of a linear inequality in slope-intercept form, remember we can just look at the inequality symbol and determine if it's shaded above or below, where the solutions are. So in this case, we have both of these are greater than type of symbols. So we are going to shade above both lines. So the area that's above the first dashed line would be, let's see, above the dashed line. And this looks kind of weird because some of this area is way down here at the bottom of the graph, but it's technically the upper side of that blue line. And then if we take a look at where it's shaded above the other line, the solid line, that would be the area here. And you'll notice that we've got a lot of different colors here on the screen. And we just talked about how a solution to the system is only if the ordered pairs that are solutions to both or all of the inequalities in this system. So in this case, where did my solutions from each shaded area overlap? And you'll notice it's where the yellow and the blue made green. It's the area that is actually above both lines. So to show my answer, I would actually not show it the way that I did here. I don't want to show all of the colors. So I'm going to undo this, clear my ink. All I want to do is show that the solutions to the system are going to be in this area up here. That's all of the ordered pairs that are solutions to both inequalities. All right, let's look at another one. Here we have two inequalities again in slope-intercept form, where we're going to shade above both lines. I can see my first inequality, greater than or equal to, is shaded above. So the upper side is going to be this side. And then for y is greater than -2, that's my horizontal line that has a slope of 0. So all the y values greater than -2 are actually above it like this. So I want to think about where are the ordered pairs that are solutions to both of those inequalities. In other words, where did my two shaded areas overlap? The yellow and the blue overlapped. It looks like it's on the upper right-hand section. So to show my solutions, I really only want to graph or shade up here. That's where my solutions to the system of inequalities exists. Number 3, we have y is less than 3. Well, let's see. That one is going to be, let's see, what there's 0 slope on that one. So that's my dashed line here. And if I want to show the y values that are less than 3, that's going to be all the ordered pairs that are below it. I'm going to shade everything below that for right now to give myself a good visual of that. Then I want to take a look at my other one, which is less than or equal to. So that's my solid line. That is a y-intercept of 1 with a negative slope. And I want to shade everything below that line because that's my less than symbol. So everything below the line down here. Again, I'm looking for where are the ordered pairs where my two shaded areas overlap. It looks like it's the lower left-hand corner of my graph. So it's below the red line and also below the blue line. So I would just want to show my solutions like this. And of course, shaded a little neater on homework or something like that. But that's the area. Everything to the lower left-hand side of the red line and the lower side of the blue line. That's the solutions to both inequalities. I'm going to go ahead and skip that one. Let's take a look at, here we go, number 5. I like this one. We haven't seen an inequality like this for a while where we have x is less than or equal to -3. That's my vertical line. It has an undefined slope because y is not even in that inequality. So for that line, I can't think of it as above or below because there is no like up or low. It's right or left. So where are the x values that are less than -3? Well, those are going to be to its left-hand side. We would shade everything to the left, keeping in mind that that goes on forever, even though my graph space ends at about -5 on the x-axis. Now my second inequality, this one's a little bit different. Notice my second inequality is in standard form. So we can't just look at the symbol to determine if we shade above or below the solid red line, my angled line. Instead, we test a point. You know, a good point that we've used in the past is 0, 0. So let's check to see if 0, 0 is a solution. If we do a quick check, if you plug in 0 for x, 5 times 0 is 0. If you plug in 0 for y, 3 times 0 is 0. And we're going to get 0 plus 0, which is 0 on the left-hand side. So we're wondering, is that true or false? Is 0 greater than or equal to -9? Well, we know it's not equal, so really, is 0 greater than -9? Think about your y-axis. 0 and then -9 would be way down here. Yeah, 0 is greater than -9. So that tells us that the test point, 0, 0, the origin, is a solution. Okay, so if the origin is a solution, or that point's a solution to the inequality with the red boundary line, I want to shade that side of the red boundary line. So let me grab my blue highlighter here. And I don't necessarily want to say it's all based on the inequality. So I'm just going to say because 0, 0 is a solution, I shade the side that contains 0, 0, which is the upper right-hand side. And really, I'm only concerned with the solutions to the entire system, which appear where the yellow and the blue overlap. It looks like it's in this little triangle slice here that, yes, it does go on forever and eventually opens up if you were to zoom out on this graph. But it's everything in that little triangle area there on our picture. So I'm going to clear this off. I'm going to go ahead and shade in this area up here to represent that's where our solutions to this system of inequalities is. All right, so here we're going to take a look at graphing our own boundary lines and determining where the solutions to the system are. So in our first inequality, we have x plus y is greater than 2. And if I want to find my intercepts, just remember we have to do a little dividing. So 1x plus 1y is greater than 2. So my x-intercept is when I take 2 and divide it by 1. Well, 2 divided by 1 is 2. Plot that on my x-axis. My y-intercept is when I take the constant divided by the coefficient of y. Well, 2 divided by 1 again is 2. The y-intercept is positive 2. I look at my inequality symbol to tell me what type of line to draw. Do you remember what type of line we should draw for this? Is it solid or is it dashed? Hopefully you remember that it's dashed because it's not equal to. We don't want to include everything on the line as possible solutions. So we're going to draw a dashed line. I think I'm just going to draw this by hand this time. Dashed line all the way across. And in terms of the shading, just kind of check, is 0, 0 a solution? Well, if I plug my zeros in for x and y, I would get 0 is greater than 2, like this. And let's see, is that true or false? 0 is greater than 2. Oh, that's false. 0 is actually less than 2, so that's a false statement. So that means that 0, 0 is not a solution. So we would actually end up shading the upper side up here. Okay, so for right now, we're just going to keep that in mind, that we would shade up above to the upper right-hand corner. You know, one thing you could do is like at the end of your line, just make a little mark. Just say, I got to shade that way. That's my arrow, sorry. I got to shade above that line. All right, let's go to the other line. 2x minus y is greater than 1. All right, let's see. That's standard form. So let's do our divisions again. Let's see, 1 divided by 2. Oh, that's 1/2. Okay, yeah, it's not real friendly, but that's my x-intercept. So 1/2, which is right between 0 and 1. My y-intercept, I take my constant term, divide it by the coefficient of y. 1 divided by -1 is -1. My intercept is right down there. All right, so when I draw my line, you know, one thing I notice here is that it's going to go, because this was at half on the x-intercept, it's basically going to be right through those points. It's got a slope of 2/1. Might help me draw a better line. All right, so my inequality symbol tells me to draw the type of line. In this case, it's going to be dashed again because it's not equal to. I want to show that it's not a filled-in line. The solutions on the ordered pairs on the line are not solutions to the inequality. It's just a boundary. And for that one, when I test a point like 0, 0, which it's close to my boundary line, but it's not quite right on it. Okay? So if I test that and plug in my zeros, I'll get, let's see, 2 times 0 minus 0 is 0 greater than 1. And again, that is a false statement. 0 is not greater than 1. It's less than 1. So the origin is not a solution to my green line either. Since my test point would have been to the upper left-hand side of the line, and that is not a solution, I actually want to shade below the line. Okay, so think about what area is above the red line but below the green line. All right, did you get it? It's this area over here. Remember, that's only my inequality lines that are boundary lines. The axes are not boundaries, so don't stop at the x-axis. It goes all the way down to the end of that red line. Okay, that's where all the solutions are to this system of inequalities.